Good morning. My name is Prashant. Today I'm going to give a presentation on climate effects on US infrastructure, the economics of adaptation for rail, roads and coastal development. As part of my presentation for the subject disaster management. Let us move on to the Introduction. Climate change is no longer just an environmental issue, it is a major economic and infrastructure challenge. According to the United States, rising temperatures, stronger storms, flooding, and sea level rise are placing increasing pressure on transportation networks and coastal development. Roads crack under extreme heat, rail lines warp, and coastal cities face repeated flooding that damages buildings and public systems. The key question is not whether adaptation is needed, but how much will it cost and how to invest wisely. So, this presentation explores how climate change affects the United States and its infrastructure and examples the economies of adapting railways, roads, and coastal development to future climate conditions. Why infrastructure is vulnerable? Infrastructure systems like highways, railroads, and coastal buildings were designed based on historical climate patterns. However, those patterns are changing rapidly. Heat waves are becoming more frequent, rainfall is more intense, and coastal flooding is more common. These systems are long lasting and expensive to rebuild. So, even small changes in climate can create major financial risks. When infrastructure fails, the consequences go beyond repair costs. These are economic disruptions, supply chain delays, and safety risks for communities. Because infrastructure supports nearly every sector of the economy, climate impacts on these systems can have widespread financial consequences. Climate effect on rail infrastructure. Rail systems are highly sensitive to temperature and extreme weather. High heat can cause steel tracks to expand and warp, which increases the risk of derailments and requires speed restrictions. Heavy rainfall and flooding can wash out tracks and damage signaling systems. In coastal areas, sea levels rise and storm surges threaten rail corridors located near shorelines. Repairing and maintaining rail systems under these conditions becomes more expensive over time. Adaptation measures may include heat resistant materials, improved drainage, and relocating vulnerable rail segments. While these upgrades require investment, they can only prevent costly disruptions and accidents in the future. Climate effect on roads and highways. Roads and highways face similar challenges. Extreme heat softens asphalt, leading to cracks and potholes that require frequent maintenance. Flooding can erode road foundations, making them unsafe or unusable. In some regions, freeze thaw cycles are becoming more intense, causing additional damage. When major highways are closed due to climate impacts, transportation delays can disrupt commerce and emergency services. Adapting roads may involve using more durable materials, elevating roadways in flood prone areas, and improving drainage systems. Although these measures increase upfront costs, they reduce long term repair expenses and improve reliability. Coastal development risks. Coastal infrastructure is particularly vulnerable to climate change. Rising sea levels and stronger storms threaten homes, businesses, ports, and transportation hubs along coastlines. Flooding events that were once rare are becoming more frequent, causing repeated damage and insurance losses. In some areas, property values are already affected by increased flood risk. Coastal adaptation strategies include building seawalls, restoring natural barriers like wetlands, elevating structures, and in some cases, relocating development away from high risk zones. These decisions involve complex economic trade offs between protecting existing assets and planning for long term sustainability. The economics of adaptation. Adapting infrastructure to climate requirements requires significant investment, but failing to adapt can even be more costlier. Economists often compare the upfront cost of adaptation with the long term savings from avoided damage and disruptions. For example, strengthening a bridge or elevating a road may cost millions of dollars today, but can prevent billions of dollars of loss in the future. Cost benefit analysis helps policymakers decide which project provides the greatest economic return. Adaptation is not just about protection, it is about ensuring economic stability and reducing risk over time. Funding and policy changes. One of the biggest challenges in climate adaptation is funding. Infrastructure projects are expensive and often require coordination between federal, state, and local governments. Deciding who pays for adaptation measures can be politically complex. There is also uncertainty about future climate conditions, which makes long term planning difficult. Policymakers must balance immediate needs with future risks. Public private partnerships, federal infrastructure programs, and climate resilience funds are some of the mechanisms used to finance adaptation. Effective policy planning is essential to ensure that investments are both economically and environmentally sustainable. Case examples. Several US regions are already investing in climate resilient infrastructure. Coastal cities like Miami and New York are raising roads and improving flood defenses. Some rail systems are testing heat resistant materials to reduce track damage during extreme temperatures. States prone to flooding are redesigning drainage systems and reinforcing bridges. These examples show that adaptation is possible and can provide long term benefits. However, the scale of required investment is large, and not all regions have created or allocated equal resources or can respond in an equal manner. So, this creates disparities in resilience across different parts of the country. Long term economic impacts. The longer term economic impact of climate adaptation extends beyond infrastructure itself. Okay, reliable transportation systems support trade, employment, and daily life. When infrastructure is resilient, businesses can operate more efficiently and communities can recover faster from extreme events. On the other hand, repeated infrastructure failures can reduce economic productivity and increase public spending on emergency repairs. Investing in adaptation today can reduce these longer term costs and create more stable economic conditions. In this way, climate adaptation is both a protective measure and an economic strategy. In conclusion, climate change poses serious risk to US infrastructure, particularly rail systems, roads, and coastal developments. These systems are essential to economic activity and public safety, making adaptation a crucial priority. While the cost of upgrading infrastructure can be high, the economic benefits of resilience often outweigh the expenses. Careful planning, investment, and policy coordination are needed to ensure that infrastructure can withstand future climate conditions. As climate impacts continue to intensify, the economics of adaptation will play a central role in shaping how the societies protect and sustain their infrastructure for the future. So, conclusion. In conclusion, climate change poses serious risks to US infrastructure. Partially, the railway systems, roads, and coastal developments. These systems are essential to economic activity and public safety, making adaptation a crucial priority. While the cost of upgrading infrastructure can be high, the economic benefits of resilience often outweigh the expenses. Careful planning, investment, and policy coordination are needed to ensure that infrastructure can withstand future climate conditions. Thank you. This is my presentation on climate change effects on US infrastructure. Thank you for listening.